Yo, welcome everyone. So in this video, we take what we've covered in the Niagara intro and substance intro and combine these together in this firework effect. I will be covering the creation of the materials, the emitters, and eventually the system itself. It will be a narrated video, and I will describe my steps and thought processes along the way. So without further ado, let's go. First off, we'll lay down the folders. So put down the textures, materials, and emitters folder. And what I did here was I grabbed the textures that were created in the substance video and dragged them into the textures folder right here. What you can also do is, if you see the add import button right there, you can also import it that way. Then you need to go to your respective folder, and then you can import them into your project in that way as well. So now I'm opening the textures themselves and define some options here. So what I'm doing here is reducing the size down to 512 and also making sure that the actual texture group is set to effects. And this will help with the compiling of the shaders later down the line. And I'm also doing it for the other texture, and I will give them the same settings because they will both be used in the effects context, and 512 should be enough in terms of resolution. So we'll start with creating the flash material first. This one can be kept quite simple. What I'm doing here is importing the texture first, and then I'm putting down the particle color. So in terms of multiplication, so what I'm doing here is that you multiply the texture on top of both the particle color and the particle alpha. And then that's pretty much all you need to do. And after you've multiplied those together, you can then plug them into both the emissive and opacity respectively. And you need to make sure that the blend mode is set to additive and the shading model is set to unlit. So right now we're going to start with the smoke puff. I will start by laying down a sphere mask first. What you see right here is that I put down a texture coordinate first, and that is plugged into the A. And this means is that I'm now defining the coordinates to be just within like a UV space. The B will define in which position it is placed in. So this will now basically mean that it's placed into the center. Then I define what the radius is, and the hardness will mean how big the fall off is from the center to the edge of the sphere mask. What you will also see is that I turned on the live update and the live nodes. So this means if you change something in the shader network, it will then automatically update as well in your chain. So what I'm doing here is I'm simply dragging in the smoke texture and drag them into the material. And then I convert them into a texture object, and this is something that is needed for the node I'm putting down now, and this is called a flow map. Now, and this is going to be used to deform the sphere mask a little bit, and this gives the impression that the smoke is dispersing a little bit. It is really solid, and I think it will do well with selling the illusion of a smoke puff. I think you can pretty much leave it as is, and only making sure that the coordinates are set within its UV space. Right here, I'm putting down a component mask, and this will basically select, this basically allows you to select the channels that you want to use. In this case, I just want to go for like a single channel and go for the green. So that's the box I ticked in the component mask. I put down 2 multiply nodes, and I use that one to reduce the strength of the clouds, and then multiply those together with the original sphere mask. And this will be put into the base color. So what I'm doing here is I'm going to basically do something with the alpha so that every spawn particle has a different outline. And I do this by putting down a dynamic parameter. This is something that you can put down if you want to access certain parameters in your material and change them in your system. What I do here is that I put down a panner, so this basically means that the texture will scroll, but the update time, you will set that manually. So that means that for every sort of cycle the texture goes through, it has a certain time assigned to it, and if you then randomize this inside of the particle system, this means that the outline of the smoke will always be different. And yeah, as you can see here, I kind of made a mistake because it turns out that the base color would turn out too dark. So what I did is change the multiply around for an add and set that to 0.25. And then for that alpha outline that I kind of discussed before, I just made sure to add those together. Now, the saturate nodes means that it will bring down all the values within a 0 to 1 range. And it's kind of like a sort of a safety measure, so to speak. In case any values go over 1, the saturate will kind of bring those down again. So now after that, I put down a 1 minus node. This is what that's called. So this basically inverts the result. So what we're doing there is, so that's going to be an input for something we're going to cover in just a bit. And I'm just making sure to multiply that on top of the alpha result after that subtract. So now I'm just making sure that the particle color is multiplied on top the first input after the saturate. So this goes into the base color. Yeah, I initially put it into the emissive color just to check, but we want this to be a lit particle. So we're now going to put down the material function, and this has been done by right-clicking into the materials folder and then search for the material function. And we're going to call this alpha erosion. So this is something that we're going to put after that subtract node. So this is something that we're going to use for eating away at the alpha so it looks like the smoke is dissipating. So we're going to have a look at how to make this, and this is something that you can then use in later effects as well. It should be seen as your first item in your library of material functions. First of all, we're going to put down an input node, and this is where you define what type of input it will be. As you can see there, the input type by default is set to a vector, and we're going to turn this into a scalar right now. Also, it is a good thing to input a certain value in there and make sure that the preview value as default is turned on. Otherwise, if you put down this function into your material, like it will start complaining because it doesn't have any input. So it's best to turn this on. So you can basically copy these inputs over, and we're going to be naming them opacity, softness, and erosion map respectively. So in this node chain that I'm building, what this does is that you put any scalar value into the opacity, and then your softness determines how tight the fall off will be for your erosion map input. So it will compare all these values together in the smooth step at the end. And the lower the values are in the erosion map, the tighter it will pack these values together, so it looks like it will get eaten away instead of fading out in a smooth fashion, so to speak. So what I did here was then I put the softness to 1, and this means I will basically have a very normal effect to it. It will not be too tight because it needs to be very smooth. The actual multiplied particle color input will be input into the erosion map, and then the actual opacity will be your alpha that needs to be eroded. Then I eventually multiply this together again with the particle color, so it will have a bit of a smooth fade out at the end, so it will catch any leftovers, so to speak. But as you can see here, there is a bit of a problem, and I will fix this in just a bit. And I'm seeing that I did not connect the inputs correctly inside of the material function itself. So as you can see, the add is going to be put into the min, and the subtract is going to be put into the maximum. And then eventually the erosion map control is put into the bottom input. So now it should be behaving correctly. Set this blend mode to translucent. So now we're moving on with the smoke trail. And what you can see me doing here is grabbing some things that were already established. And what we're going to do here is use this sphere mask as a linear gradient, basically. So there's this function called linear band, and this is using the same technique for the sphere mask as I'm using right here. So what you do here is laying out the coordinates in just one direction and then making sure that it is centered. So then you can have like a linear gradient. So that's what I'm doing here. So what I'm doing here is I'm laying down a world-aligned texture node. So this will be basically used for breaking up the ribbon. So what this does is we'll basically simulate the dissipation of the smoke. So then we will feed this into a erosion map as well. So the actual texture size will be in Unreal units. So this means that in this case, the texture will be laid out over a distance of 128 by 128 Unreal units. And then the other one is set to a sort of a larger scale. And then we eventually put this into another component mask so we can then choose the respective channel. So what I'm doing here is grabbing the bottom component mask and then subtract it from the sphere mask. So what this does is this will break up the silhouette of it. Then what I do is grab the other channel and add this back together onto the subtracted result, and this will then be used as the base color. And just make sure to multiply this with the particle color as well, and then plug this into the base color. So what I'm doing here is putting down the alpha erosion material function. We put the actual softness to a lower value. And then we put the subtracted result into the opacity. So what we do here is grabbing the world-aligned noise and put this through an add node so the contrast will get lowered. So then we subtract the inverted result of the particle alpha. So this means that the particle will start off as opaque, but as the alpha decreases, the subtraction will get bigger. So this means more of the cloud noise will get taken into account into the subtraction within the alpha erosion. And eventually put this into the erosion map. And what we then do is add a depth fade just to make sure you don't see any visual harsh lines with meshes. And multiply this together with the alpha erosion result and then plug this into the opacity. What we also do here is making sure that the actual overall opacity will be a bit lower, so the smoke will be see-through. So it needs to not to be too apparent. And that should be it for the smoke ribbon. So the final thing we need to do is making the sparks. It's best to go for something that doesn't look too uniform, because you would like to refrain from using actual like spheres as sparks, something we kind of refer to as math dots. It's best to get something custom going on if you can do it. The result will look a bit more realistic and also will look better. We're going to make this sort of a bit procedurally. So we're just going to grab one of the sphere masks from the other material and paste them into the new one. Also make sure that the blend mode is set to additive. You can pretty much leave the first one as is, but make sure that the first sphere mask is laid out vertically and then the other one is laid out horizontally. And increase the hardness to 0.5. And then we multiply these together. So then we multiply the result with the particle color and the particle alpha. I added a depth fade in here just in case. So this is just when like a spark will intersect with the ground or something else that's high up in the sky. Like it's not really that necessary in this case, but mostly used as a safety option, so to speak. So now we're going to put down all the emitters and the system. So what you do is right click into the field of the particles folder, go to FX and then make sure to select the empty preset. So what we'll do is we can leave these emitters just as is. And the reason we set it up this way is because it is quite a small project, but so let's say if you have like a lot of different types of particles, so it is very good to set up categories for the emitter types you need. So this will make things a little bit more manageable. You can see the relationship in this case as a master material and a material instance type. Because what you can do is you define all of your commonly used parameters in your emitter, but then you're still able to change all of those values later inside of your system. So if you now open up the system, you see that completely empty emitter there. You can just delete that. And then we drag in the sparks emitter and let's start with that. These are going to be the lead particles for the fireworks. In the sprite runner, we're going to be putting down the actual sparks material as the material, and then make sure that the alignment is set to velocity aligned. So this means that the alignment of each particle will be the same as the velocity vector. So put down the spawn rate and tick on the spawn probability. So this will randomize the spawn rate a little bit. Set the lifetime to 0.5 so we can keep this quite uniform. Something we will tick on now is the mass mode and set this to direct set. So what this will do is this will more accurately determine any size changes or rotational values based on a more like realistic approximation. And then in the particle spawn, we will also be putting down a calculate size by rotational inertia by mass. And you can leave that as is. So in the mass mode, we'll set this to a mass of 400 because they are quite big. I also put down the apply initial forces. And then add a velocity in cone. And we'll make sure that the actual velocity is randomized. And set the cone axis to Z. The cone angle is then set to 50 because there's a little bit of spread that we want to add. Then we add a bit of drag in there, and as you can see, it needs to be put into the solve forces and velocity because, like we covered, the order is really important. So then we put the gravity force down and leave that as is. Then we can put down a scale color and turn that into a linear color. And you can leave that as is. Initially, I wanted to sort of give the lead particles a bit of a flickering glow. But I initially put this in scale alpha, but this was kind of a mistake. And what we then do is revert the scale RGB back to default. In the drop-down, select multiply by float. And then we multiply that float again with a sign. And then put in the values that are given right there. So this will make sure that it gets a bit of a like slow flickering glow. So then we put down a scale sprite size by speed. So what this does is then this will stretch out the particles based on a certain speed threshold. You can set the x for both options to 0.5 and then the y set that to 2. So that should be fine enough. So what we do here is we lay down a location event. So this will basically be a prompt to check what a certain particle needs to do on a given location. As you can see, it will give an error because by default, the option of requires persistent IDs is not on. So this will mean that like every spawn particle will be given a certain number that will not change. So this will help solve the error that is given right here. And then we also put down a generate death event. So this will make sure that it gives you a prompt on what a certain emitter needs to do when this particle has died. So what the gap correction amount does is, for example, if the trail or a certain event is like in front or like lagging behind, you can correct this by dialing a certain number in the gap correction amount. So this is just in case you need it. So that should be it for the leading particles. So to keep things easy, we are now going to be copying over the sparks emitter and then make sure that the generate depth event, the generate location event, and the spawn rate are all deleted. So what this will eventually be is a spark trail. So the overall parameters are already quite defined here. So the only thing kind of need to do is to make sure that they are a bit smaller. The reason we will delete the spawn rate is because we're going to let the sparks be spawned by the event handler. So we're going to add that now. And then make sure to select the location event. And this will refer to the location event that has been defined in the first sparks emitter. Also make sure to add the receive location event in the event handler section. And then we're going to vary the inherited velocity scale a little bit, making sure it's a random ranged float. So if we go back to the event handler properties, we'll dial in some numbers for the amount of sparks that need to be spawned. Also, do not forget to delete the apply forces in cone. But as you can see, it is not doing it correctly because it now will do the event location for every spawn particle. But we need to change this to just the particles that are spawned, so it will now just follow it. What we'll do now is going to add a scale sprite size. So what we'll do here is multiply the vector 2's together and then turn the float 2D into a single float and then turn that float into a curve. So as you can see, we're just now scaling them down over life and give it a curve that you're happy and give it a curve that you are happy with. So we'll just reduce the mass here so they become like a lot smaller than to be like very fine. And then we'll make sure to reset the color options here and then turn it into a color from curve. So we'll make sure that the intensity will get reduced over its lifetime. So and what we'll do here is just making sure that there's a little bit of offset in the trail so they do not become too cluttered. And we'll just do that by adding an add velocity from point and randomize the velocities a little bit. So one thing to note is that although you might see that the amount of particles is quite high and you're better off turning these into GPU particles for this, the unfortunate thing is that all the events don't work with GPU particles, as far as I know. So just keep that in mind. And what I did here is turn on the stats, and this is something that has been recently added into 4.26. And this is just to visualize how much a node will contribute to the overall cost of the emitter. So we will now copy the spark trail and we will turn this into the peony part of the fireworks. So I just went back into the spark tail because I saw that the lifetime was still uniform. So I just changed it up by adding the random range flow to it. So now onto the peony part. So what we'll do first is delete the receive location event and change it over to a receive death event. And then we need to make sure to set the source to the death event and then reduce the max events per frame to 1. And then set the spawn number to like 75, what I did here. So this will represent the amount of stars the peony has. What I saw is that the gap correction amount was a little bit too high, so I reset this again to 0 because this was actually enough. And now we'll go back into the end velocity from point and reset it to its original value. So now we have a uniform strength, so you get the perfect like spherical look. And in this case, just make sure to give some variation to the overall lifetime of these particles. It needs to be a hard-hitting burst, but the stars need to dissolve relatively quickly. And what we also do here is to dial up the mask mode quite a bit. So these are the brightest bits of the overall effect. If you go into scale color, we can just give it a different color for now, but we will revisit this later on because we are going to add some user parameters to it, and this allows you to change the color of our particles once they are placed into the level. But some more explanation will be given later as well. So now we are going to drag in one of our burst emitters. We're going to take care of that now. So now make sure to add the flash material in the sprite renderer. Then add an event handler and then set the source to the death event. So what we'll do now is basically let one flash spawn if one of the leap particles dies. Now make sure to add a scale color, and we're going to then turn this into a color from curve. So in the size properties, you can basically set the size mode to uniform and give it a size of like 750 and set the lifetime to something quite short. In this case, I put it to 0.1. So what I'll do here is basically scale the flash up quite rapidly, so it gives a bit more impact. So now I do this just by making sure it starts from 0 and then rapidly scales up to like its original size. And what we also do here is add a light render to it. Then we make sure that the effect translucency is on and turn off the inverse square law at fall off. So now the brightness and intensity of the light will be determined by the actual color scale. We'll turn the color into sort of a desaturated orange and make sure that a little bit of color comes through. One thing for the color scale is that the top row will define what the color will be, and the bottom row will determine its alpha value, basically. So that is the flash done. And now we're going to start working on the smoke. I'm going to start copying over the flash we just worked on and then work from there. So in the sprite renderer, make sure to change the material to the smoke puff material. So what we'll do here is just tweak the scale sprite size a little bit, so it like scales a bit more in a gradual fashion. So it will still scale up quite fast, but there's still a bit of a aftermath where the smoke will still expand a little bit. So now we'll go into the colors, because now it's just way too bright. We're going to just reset it to its default colors and then turn it to sort of a lightish gray. And what we'll do then is turn the scale alpha into a curve and make sure that it has a kind of a sloped down fall off. And then make sure to set the lifetime to something quite big. 1.5 in this case should be enough. So what we'll do now is add a dynamic material parameters into the spawn, because what we'll do here is make sure that the look of each smoke puff is randomized. And since it doesn't need to change over time, we can simply put it into spawn. And if all is well, your defined parameter name should pop up. And in this case, I called it random offset. And then make sure to set it to a random float. It can be left from 0 to 1, because that should be enough. Also make sure to activate the sprite rotation mode and set it to direct normalized angle, and then also turn it into a randomized float. So it will now spawn the particles in a randomized 360-degree angle. So we will now move on with our smoke trail, and what we'll do now is drag in our ribbon emitter. And then make sure to add a event handler. And a receive location event. Set the source to location event and make sure that the evaluation mode is set to spawn particles. So as you can see now, it's already working, but it's kind of on the small side. Make sure to set our lifetime to 2 and turn up the ribbon width quite a bit. So just for convenience, we'll just simply drag over our scale color from the smoke burst and copy it over by clicking on the node and holding Control and dragging it over to our particle update for the smoke trail. We will also add a curl noise to the particle update. So we'll just add a little bit of disturbance into our smoke trail and then make sure to put it above the solve forces and velocity node. And make sure that the force is quite low, as well as the noise scale. So that means the frequency in this case. So that means that the trail doesn't become too erratic in movement. So what we'll do here is create a scene to place our effects into and just speed it up just a tiny bit. What I'll do here is making sure that it's sort of in a darker context and like quite foggy as well. So we're now just going to place it in our level and make sure everything looks all right. And we're going to now move on to adding our user parameters, so we can just change it in any parameter we want once the particle is placed inside of the level. And we then can also make sure that anything that you don't like about the effect is also tweaked just a little bit. As you can see here, just making sure that the ribbon width is just a bit wider. I think that's all there is to it. So we're now going to add our user parameters. So if you click on the plus sign in the user exposed, you will be greeted with the type of parameters you want to add. So we will just start with adding 2 flow parameters and name them spawn rate and spawn probability. Also, if you go to the blue system node and click on user parameters, there you will find all of your defined user parameters. And if you want to place this on your parameters that you would like to change, simply drag one of the created parameters over to the desired node and drag it onto the slot, so it will then refer back to that specific user expose parameter. Also add a linear color called tail lead color. And add a color curve for the peony color. And as you can see, it's already starting to work inside of the editor. So now if you go to your override parameters, you can see that all of your defined parameters that you just created are showing up there. Just play around with it a little bit just to see what you like. And if anything is still not up to your liking, then you can still change it. And if anything else, or if there's anything else you would like to expose, it's only a matter of adding the right user parameter type and then assign it to the node you want to adjust. And here I just went into the smoke material again because I saw it was not really to my liking, and simply scaling up the smoke was good enough in this case. And there you have it. I really hope you guys enjoyed this series. If there are any questions, do not hesitate to post them down in the comments, and I will make sure to answer them to the best of my abilities. Thanks so much again for watching, guys. Bye bye.